As we have said, using angular measurements is a very helpful way to describe how we compensate for the drop of the projectile over distance in order to hit the target, or the elevation adjustment. It can also be used for windage because by the same token, once again, it's an angular dispersion. So in this case, what we're talking about here is minutes of angle. And as the name suggests, we're referring to a degree having 60 minutes, same as you can use it for longitude and latitude or time. 360 degrees, therefore, has 21,600 minutes inside it. And therefore, what we've got is a nice, large number inside our circle, which enables us then to minutely control the amount of angle we use over distance. And that's the reason we use something like minutes of angle, because a minute of angle will enable us to make some very simple adjustments. For example, we have calculated that 1 minute of angle equals approximately slightly larger than 1 inch at 100 yards. Or 10.4 inches at 1,000 yards. Very simple numbers to work with in an angular measure of the drop between when we shoot that bullet out of our muzzle and when it then dives down and penetrates the target in simple English terms. So an MOA is just a convenient way of talking about that angle of elevation. And our scopes, when we buy an MOA scope or we use the BDC or bullet drop compensator reticle, can be measured in this way. So in a scope in the US, on average, every click is 1/4 of a minute of angle, so that we have ultra precise ways of being able to describe the drop that we want for that specific target that we're aiming at. And we can do multiple clicks in order to get an accurate drop precisely onto our target out at distance. The great thing about the angular system, as we can see, is when we do calculations, they increase proportionally with distance. That means that we can say 1 MOA is 2 inches at 200 yards, or 2 MOA is 10 inches at 500 yards, because it's 2 times 5 inches, because it's proportional. 1 inch equals 1 MOA.